Hello everyone, welcome back to our channel. We are back again with a new video. In this video we are going to create a 3D surface of revolution paraboloid using Python. So let us start this by importing the required libraries. So here NumPy, which is a numerical library that provides efficient ways to work with arrays and perform mathematical operations, and matplotlib.pyplot, a plotting library used for creating various types of graphs and plots. It is commonly used for 2D plotting. And MPL toolkits.mplot3d. This is a module from Matplotlib that provides tools for 3D plotting. Specifically, Access 3D is used to create 3D plots. And now we'll define the function for the paraboloid. So here fx, this defines a function that calculates the square of the input x, creating a simple parabolic shape when plotted in 2D. And now we'll create the data for the plot. So this generates 100 equally spaced values between -3 and +3. And this generate 100 equally spaced values from 0 to 2 pi for a full revolution. And this creates a mesh grid from the x and the theta values. So here the first line x is equals to np.linspace -3 3 to 100. This generate 100 evenly spaced values between -3 and +3. So these represent the x coordinate for the paraboloid, and theta is equals to np.linspace. This generate 100 evenly spaced values between 0 and 2 pi. So it represent angles for a full revolution around the z axis, and x theta is equals to np.meshGrid. This line creates a 2D grid of x and theta values. It returns two 2D arrays x and theta that correspond to the coordinates of a grid in the 3D space. And now we'll calculate the coordinate for the 3D surface. So this creates the 3D surface plot using x, y and z coordinate calculated earlier, and CMap is Inferno, which specifies the color map to use for coloring the surface, and Inferno is a popular color map that ranges from dark purple to bright yellow, and edge color is none, which ensures that there are no lines around the edge of the surface, and alpha is 0.7, which adjusts the transparency of the surface to 70%, where 1 is fully opaque and 0 is fully transparent. And now we'll label the axis and set the title of the plot. So ax.setTitle sets a suitable title to the plot, and ax.setX label sets the x-axis label, and ax.setY label sets the y-axis label, and ax.setZ label sets the z-axis label. And here at last we'll display the plot. So here we can see a 3D surface of revolution. So thanks for watching this video.